So looking at questions 5 and 6, number 5 says, how many ways can I rearrange the letters in the word pencils? So I can put the P in any spot, the E, the N, the C, the I, the L, and the S. So if I want to know how many ways I can rearrange these 7 letters, I'm just going to take 7 factorial. Number 6 is going to lead us actually into our permutations and combinations. We want to know how many ways can we rearrange 3 of the letters in pencils. So I would create my 3 spots here. And for the first spot, I'd have 7 different choices. Then in the second spot, I'd have 6 different choices. And in the third spot, I would have 5 different choices. This is going to lead us into, as I mentioned before, permutations and combinations. When I'm rearranging or choosing R out of N objects, if the order matters, I'm going to use a permutation. So for number 6, I would use a permutation. If I'm creating different values to things like a principal and a vice principal, or a chairperson and a vice chairperson, where the order is important, I'm going to use a permutation. If I'm just choosing R out of N objects and the order is not important, that's going to be a combination. This is just creating groups of R out of N objects. So now I can redo question number 6 using a permutation. I want to know how many ways can I rearrange 3 out of the 7 items. So since the order is important and there's a difference between writing P-E-N or E-N-P, I want to count these as different orderings. I'm going to take 7 permutating 3, which you can do by hand, shown here, or you can use your graphing calculator or scientific calculator and use 7, go to math probability down to a permutation 3, hit enter, and it'll give you 210. Looking at 8, 9, 10, and 11, we want to choose whether or not it's a permutation or a combination. Number 8 says that 8 runners start a race. How many ways can first, second, and third place be awarded? Here, the order matters. There's a difference between getting first place or second place or third place. So if the order matters, I want to know how many ways can I permutate 3 out of the 8 items. So I'm going to take 8 permutating 3, and that's going to give me 336. Look at the difference between 8 and 9. In question number 9, there are 8 people on the track team, and we want to know how many teams of 3 can be created. Here, the order doesn't matter. It doesn't matter if I'm creating a team of 3, let's say me, Mickey Mouse, and Donald Duck. If Mickey Mouse gets picked first, and I get picked second, and Donald Duck gets picked third, or if I get picked first, and Donald Duck gets picked second, and Mickey Mouse gets picked third, we just want to count that as one group. We don't want to count the ordering as different orders. So when the order does not matter, I'm just creating groups, I'm going to use a combination. So this time I'm going to take 8, combination 3. For number 10, 10 people serve on a committee, and how many different ways can a chairperson, a recorder, and a treasurer be chosen? Again, this one goes back to a permutation. The order matters. There's a difference between being chosen as the chairperson, the recorder, or the treasurer. So if I'm choosing from 10 people, I'm going to take 10 permutating 3, and I'm going to use a permutation because the order matters. For question number 11, you are listening to music and you have time to hear only 3 songs from your playlist of 16 songs. How many combinations can you make? This time I'm choosing a combination because the order doesn't matter. If I'm choosing a group of 3 songs, it doesn't matter what order I put them in. I only want to count the group once. I don't want to count the different ways I can rearrange the 3 songs in that group. So if the order does not matter, I'm going to use a combination.